Hi guys, welcome to Expressions and Equations, Lesson C, Topic 3, Solving Multi-Step Equations. In this video, we are going to apply inverse operations to isolate the variable and solve multi-step linear equations involving integers, fractions, and decimals. We are also going to evaluate the equation by substituting the value of the variable to check if the solution is correct. Let's get started. Solving multi-step equations with the variable on one side of the equal sign. So, what is a multi-step equation? A multi-step equation is an equation that usually requires you to simplify the equation before trying to solve. You may have to use the distributed property to remove parentheses or combine like terms. Then apply inverse operations to isolate the variable. We usually follow these steps. Distribute if needed, combine like terms if needed, undo the constant term with addition or subtraction, undo the variable term with multiplication or division, and then solve and check. Let's practice. 5x minus 2 times x minus 1 equals 16. Let's first ask ourselves, is there anything to distribute? Yes, there is. There's a 2, not just a 2, but a negative 2 right outside of these parentheses. So we are going to distribute the negative 2 to the x inside of the parentheses and to the negative 1. So that would make a negative 2x and a positive 1. So we would end up with 5x minus 2x plus 2 equals 16. Now, are there any like terms to combine? Yes, there are. We have a 5x and a negative 2x that are like terms, and we can combine those to make 3x. And don't forget about the plus 2. Now we can go to actually solve because we have a two-step equation. So we will use the inverse of addition or subtraction to undo the constant term. So in this case, the constant is a positive 2. So we are going to use the inverse of addition, which is subtraction, and minus 2 from both sides. When we minus 2 from both sides, we end up with 3x equals 14. Last but not least, we need to use the inverse of multiplication or division to undo the variable term. If we look at the variable term, we have a coefficient. The coefficient is 3. And remember, coefficients mean to multiply. So we need to use the inverse of multiplication and divide both sides by 3. And yes, sometimes we will get ugly answers like x equals 14 over 3. But we still have to check them. It's pretty nice if you have a calculator on handy for this type of thing, but if not, it's important to know how to work with these fractions. So check your work. 5x minus 2 times x minus 1 equals 16. We are going to substitute 14 over 3 into the x values. So we will have 5 times 14 over 3 minus 2 times 14 over 3 minus, by the way, I put 3 over 3 here. So we can easily see that we can work with these fractions. Okay? 3 over 3 is the same thing as 1 equals 16. And remember, with multiplying, straight across. So 5 times 14 is 70. 70 over 3 minus 2. And remember, we can do 14 over 3 minus 3 over 3, which is 11 over 3. So we're going to end up with 70 over 3 minus 22 over 3, all equal to 16. So 70 minus 22 is 48 over 3. And guys, 48 divided by 3 is actually 16. So 16 equals 16, and we are correct. Next example, 12.6 equals 1.2 times x plus 3.5. Uh-oh, don't let the decimals scare you. Just use your steps. Ask yourself, is there anything to distribute? There is. We're going to distribute the number 1.2 to the x and to 3.5 inside of the parentheses. When we distribute, we end up with 12.6 equals 1.2x plus 4.2 because 1.2 times 3.5 is 4.2 and 1.2 times x is 1.2x. Are there any like terms in this equation to combine? Any like terms over here? No, there are not. So we're going to skip this step and go straight to solving. So look at the constant term. Use the inverse of addition or subtraction to undo the constant term. So we have a plus 4.2 on the same side as the variable. So we need to minus 4.2 from both sides. When we minus 4.2 from both sides, we end up with 8.4 equals 1.2x. Our last step is to use the inverse of multiplication or division to undo the variable. Most of the time it is going to be division, and because it's going to be a coefficient with these type of equations, but sometimes it might be multiplication. So when I say not, most of the time it's going to be division, I mean most of the time we're going to end up doing division. It's going to be the inverse of multiplication. So 1.2 is the coefficient, so we need to use division to undo this coefficient. So 1.2x divided by 1.2 is 1, and then 8.4 divided by 1.2 is actually 7. So 7 is equal to x. We need to check that though. So thankfully, it's a whole number. It'll be a lot easier to check than that last one. But we're going to check our work. So our original equation was 12.6 equals 1.2 times x plus 3.5. So if we were to substitute our solution in, we would have 12.6 equals 1.2 times 7 plus 3.5. And that's 12.6 times 1.2 times 10.5, which is 12.6 equals 12.6. Again, it might be a lot faster to check your work with a calculator, but if this was a calculator inactive test, it would be cool to know how to manipulate variables and do it without a calculator. But if you're doing homework, feel free to use the calculator. Speed up the process. 1/3 times x plus 6 equals 7. Ask yourself, is there anything to distribute? Yes, there is. We actually have this 1/3 directly outside of the parentheses. So that 1/3 is going to be distributed to the x, meaning x over 3, or 1/3 x. And the 1/3 will be distributed to the 6. 1/3 of 6 is 2. So we'll end up with x over 3 plus 2 equals 4. Now we ask ourselves, are there any like terms to combine? No. If we look on the same side as the variable, there are not any like terms to combine. So we get to skip that step and go straight to solving the equation. We will look at the constant of positive 2 and use the inverse of, in this case, addition to move the constant to the other side. So we are going to minus 2 from both sides. When we minus 2 from both sides, we are left with x over 3 equals 2. Last but not least, we need to look at our variable term. And this is one of those cases, how I just said you usually will use multiplication. This is one of the cases, and I did this on purpose so that you can see what it would look like in a multi-step equation if you had a fraction at the end. So if you had a fraction at the end, you know, oh, x is on and x is on top. All you have to do is get rid of that denominator by multiplying both sides by that denominator. So that leaves us with x equals 6. And don't forget to check your answer. I know this can feel redundant, but it's important. So our original equation was 1/3 times x plus 6 equals 4. So if we substitute our value, we will have 1/3 of 6 plus 6 equals 4, or 1/3 of 12. 1/3 of 12 is the same thing as 12 divided by 3, and that is 4. So 4 does equal 4. Let's look at the next one. 6x minus 3 minus 2x equals 9. Is there anything to distribute? Do you see any parentheses? No. So we're actually going to skip that step. Are there any like terms to combine? Actually, yeah, there are. We need to combine 6x and negative 2x to make 4x minus 3 equals 9. So now we have a two-step equation, and we can go straight to solving. Look at that constant and determine what you need to do. That's a negative 3 on the same side as the variable term, which is 4x. So we need to add 3 to both sides. When we add 3 to both sides, we end up with 4x equals 12. Last but not least, we're going to use the inverse of multiplication or division to isolate the variable. This is a coefficient, so that means it's multiplication, and we need to use the inverse of that, which is division, and divide both sides by the coefficient of 4. When we divide both sides by the coefficient of 4, we end up with x is equal to 3. We definitely need to check the answer. So we originally had 6x minus 3 minus 2x equals 9. If we substitute our 3 in for the x, we will have 6 times 3 minus 2 times 3 equals 9. Or 18 minus 3 minus 6 equals 9. Or 18 minus 9 equals 9. Or 9 equals 9. We are correct. Last example is 30 equals negative 2 plus 4 times x plus 3. First, we need to ask ourselves, is there anything to distribute? Yes, there is. We see a positive 4 directly outside of the parentheses. So we will go ahead and distribute that positive 4 to the x and the 3. Ending up with 30 equals negative 2 plus 4x plus 12. Then we ask ourselves, are there any like terms to combine? Yes, there are. On the side of the variable, negative 2 and 12 can be combined to get 30 equals 4x plus 10. Now we have a two-step equation, and we can go straight to solving. So use the inverse of addition or subtraction to undo the constant. So the constant here is positive 10. We need to undo that constant by subtracting 10 from both sides. When we subtract 10 from both sides, we end up with 20 equals 4x. Last but not least, we will use the inverse of multiplication or division to officially and finally isolate that variable term. If you look, we have a coefficient. That coefficient indicates that there's multiplication, and we need to use the inverse of that. So that means we're going to divide both sides by the coefficient of 4. When we divide by the coefficient of 4, we get that x is equal to 5. We still need to check our answer. We had 30 equals negative 2 plus 4 times x plus 3. When we substitute our 5 in for the variable x, we will have 30 equals negative 2 plus 4 times 5 plus 3, or 30 equals negative 2 plus 4 times 8, which is 30 equals negative 2 plus 32. And negative 2 plus 32 is equal to 30. 30 equals 30, and we are correct. Thank you for watching the video.